All right, so this is the review that we're going to give a try. It's got a lot of FRQs, and that's good, so we don't just practice multiple choice, but we go through the questions and talk about it, so the review is right there. And number one, I'm going to give you a minute. Whoops! I'm going to give you a minute to look at this and see which one is a legitimate probability distribution. Go. Okay, so you're looking for the models that add to 1. Those are the legitimate. We want to know which ones does not. So which ones are not legitimate probability models. So this adds to 1.1. He is not legit. This adds to 3, 5, 6, 7, 8, 9, 10. This one's a legitimate model. Look over here, 0.3, 0.3, and 4. This is a legitimate model. So 1 and 3. I could keep checking and I could check 4. 4 is not legitimate because it cannot be negative. Probability is 0 to 1. What did I do?
It's B.
Yeah.
This 3 is legitimate.
Oh, I'm sorry. 3 is legit. My B. Sorry. I got you. Okay, which ones are not legitimate? These are good, so they should not be your answer. Anything with 2 or 3 is not your answer. This is your answer, which is B. My bad. Okay. Which of the following is not true of discrete probability distributions? Now this, we're not going to do tons of multiple choice. We're going to get into FRQs here also. So go ahead and go. So again, this is a not true. So does the sum have to be 1? Yeah, every probability model must sum to 1. So this is a true statement, and since we want not true, we will not look at A. The graph of the distribution exhibits symmetry. Sometimes it could, but sometimes it doesn't. This is your right answer.
What does it mean?
Okay, so symmetry means it is a normal curve. But is every model a normal distribution? No. Let's say that you are going to do 10 trials of something that has a probability of 0.2. Let's say the probability of winning is 0.2, and you're going to do 10 trials, right? So you would expect, if we did this, you would expect the shape, sorry, I made it, you would expect the shape to be, the shape is going to be weird. How many successes would you expect to have? If the probability is 2, how many would you think you're going to have? Probably 2. That's what we can expect, right? So if we did this, we could build a probability model, which this is more than you need to do, but I just want you to understand it. If you did 10 trials and the probability of being correct is 2, 0 has an answer of 0.10. Okay, so we would have a block here if this is 0.10. And 1 is going to be 0.26, so 1 is here. 2 is going to be 0.30, which you told me. 2 is the expected. It's the highest, right? So this is 0, 1, 2. 3 is going to start to do what? So 3 is going back down. And then it's going to keep going down, but it's going to trail all the way out to 10 trials. So it's going to end up being skewed right.
So is it expected always the highest?
That's such a good question, and I want to say yes, but I would have to really look at a lot of models to be able to answer that question. Definitely for this, we just did it. It is for sure a yes. Okay, so the value of the standard deviation can be less than, equal to, or greater than the value of the mean. I don't think your standard deviation is ever larger than your mean. Yeah, so that was kooky. Each probability in the distribution must be greater than or equal to 0 and less than or equal to 1. Well, each probability cannot be, that's true. And all of these statements are true, that's false. All right, so which of the following must be true? Go. You're on number 3. Okay, so do you pick one of these that you liked? C or D? So we like C or D. So which of the following must be true? The mean of X and Y is the difference if they're independent. Independence is required for what? There is a requirement for independence. They're actually applying it in the wrong place. It is not required for means. What is it required for? Standard deviations. You must check for independence for standard deviation. So this answer is actually wrong. Means, you can calculate a difference in means, but you cannot calculate standard deviation unless you can assume independence. You must know that they are independent. So I'm going to throw out none of the above because there's a good answer here. So now I've narrowed it down to 3 possibilities. How about D? X minus Y is a random variable with a mean equal to the larger of the 2 means. If my mean of X is 5 and my mean of Y is 3, and you say 5 minus 3 is 2 equal to the larger of the 2 values? No, that's silly. So now it's A or B. Which one do you think it is? B. It is B. Now, I hope that you would look at A and you would be like, when did I ever multiply 2 like that? Like, we've never done that. We know that the mean of X minus Y is the mean of X minus the mean of Y. There's no extra step in there. And I know that if I multiply the variables, that's the same thing as that. I mean, that all you're doing is taking the mean and multiplying by 3, taking the mean and multiplying by 2, and then adding them together. That's perfect. All right, next, great question here with the basketball player and the free throws. You are looking at the binomial formula. Let's talk real quick about why we know it's binomial. Remember, binomial is bins. There's a set number of trials. What's the probability of success? 70%. Are each shot independent? Yep, they told you independent. And do you have success or failure? Yep, they make or miss. So that's how we know it's binomial. Now, have you ever seen a 2 out front like this? No, that's kooky. Get rid of that. Have you ever seen these factorial symbols? In Algebra 2, I hope you go, yeah, I saw that. We've never seen that. So I'm going to narrow it down with you to B, C, or D. It is on your reference sheet. So if you're looking at this and you're like, what the heck is that weird formula? It's there. And she says the answer is B. We got to vote for B. Yeah? Yeah? What you got? Are you voting?
Yeah.
He said it's B. So there are 7 trials. You want 5 successes. So your success is 0.70 to the 5th power. 70 to the 5th power. I was thinking of the 5th power. And failure is 0.30 to the 2nd power. Because the sum of these two must be your number of trials. I always look at that sum and I exclude the ones that have the wrong numbers there. Number 5, go for it. Bless you. There's a little bit of work that goes into this question. If you are stuck, I want you to calculate the mean, and I want you to calculate the standard deviation using the formulas on your reference sheet. Not the mean. It's a sample size times success times failure and then square rooted. So I hope for the mean you said 0.70 times 130 which is 91. My mean is 91. And then for your standard deviation, you said my sample size is 130 times success times failure. .225. And then it says the interval for the number of infected fish within 2 standard deviations of the mean. So I'm going to take 91. I'm going to add 2 standard deviations. I'm going to subtract 2 standard deviations. So 91 minus 2 times 5.225. And 91 plus 2 times 5.225. Because it said 2 standard deviations.
Why wouldn't it be like 34?
Because we never said it's normal.
Oh, okay.
And 34%, right, are within 2, but that's only if it's normal. And they're not asking me for percents, they're asking me for the interval values. What? Okay, so that's what I'm doing. So I got 80.55 and 91 plus 2 standard deviations is 101.45. So I would go with A. Now, I'm going to tell y'all that's a really good question because you have to be careful because anytime we talk about standard deviations, your gut tries to go to a normal curve. Not everything involving standard deviations is a normal curve. It's just a distribution. Every distribution can have a mean and have standard deviations. All right, number 6, go for it. Okay, so is this binomial or geometric? Binomial because the number of trials is 10. There are 10 trials, so this is binomial, 10 trials. We know our probability of success is 0.3. So, how many people would be required for there to be not enough people? How many staff are there? 2. So there, oh hey, do you think you could staple this for me? Sorry, I hate to ask you to do stuff like that because I know that's tough. It'll just help me out. And then throw it in that white bucket up there. Okay, so 2 people, we're good. What if we need more than 2 people? Are we good or do we not have enough staff? We don't have enough. So we want to know what is the probability that X is greater than 2. Well, how many people would be greater than 2? 3, 4, 5, 6. So 3, 4, 5, 6, blah, blah, blah. So we want to know what's the probability of this happening. So what's the probability that X is greater than or equal to 3? Well, I can't do greater than or equal to. What do I have to do? 1 minus the probability that X is less than or equal to 2. So I want 1 minus binom CDF that X is less than or equal to 2. So there are 10 trials. The probability of success is 0.3 and the number of successes is 2. Because that would mean that there's more need than there are people on the floor. When I first read this question, I was like, what? But then as I thought about it, I was like, okay, if 3 people are needed, we don't have enough people. And the answer is 0.3827. 78, which is 3828, so that's A. Didn't I subtract it? Oh, I'm sorry. 1 minus second vars binom CDF. You are correct. It is the flip of that, 0.6712. So this is 1 minus 0.3828, which is 0.6172. Yes, sir.
So every time the answer is greater than, you have to
We are, now, you may have a really new calculator that does the tail. And if your calculator does the tail, you may be able to do greater than, but most of us do not have calculators that'll do the tails. Does yours? Because I noticed on your quiz it looked like it does the tail. It does. And you don't know whether you're doing it right, but somehow you're getting lucky. All right, so here we go, number 7, hit it. And then we got free response, free response, free response. Okay, what are you thinking? It's none, because you're not replacing the cards. It is none. If you flip a card and you don't put it back, then what is happening to your probability every single time? It's changing. If you don't get success, it's higher. If you get success, then it drops lower. So the probability is not set. Therefore, it's none of the above. It's not geometric. It is not binomial. I don't even know what this uniform would be, like constant success every time. I don't know, so that's not it. All right, I'm so happy we have this question. I want you to take a minute, and I want you to choose discrete or continuous for A through D, because we miss this question on our quiz a lot. But in class, we were like, oh, so let's put it to the test. Okay, Easton, what do you think about the height of a female? I agree. The number of children in your family, Maddie. Discrete. The amount of sugar in an orange. Continuous. And Friday night attendance at a play. Discrete. Have we figured it out? No? Yes. If it's something that can be drilled down and drilled down and drilled down, because there are more accurate measures to, more accurate ways to measure, and you can keep getting more and more specific, it is a continuous random variable. If it is a number to where you cannot have 4.324157 people at the school play, there are either 4 or there are 5, but there's no decimal in the middle. That is a, she's like, nah, maybe. That is a discrete variable. Okay. Here we go. What is the expected payoff for this game? So a game pays a player $5 for rolling a 3 or 5 with a single die and nothing for any other roll. Suppose you have played the game 10 times and won 8 times, therefore winning $40 for an average of $4 per game. So you have a 0.8 chance of winning how much money? 5. And you have a 0.2 chance of winning 0. and your expected is $4. So how would I say this if I had to interpret? If you play the game many times, okay, to win an average of $4 per game. Do you think I made it wonky? Okay, all right, I think we got a little wonky on this, so these poor people at home that are not with us to know the conversation we just had. Okay, we're gonna go back. So, we never factored in, I was just looking at the outcome thinking there was something to do with the outcome. My B, here we go, we're gonna look at this. They have $5 for rolling a 3 or a 5. So $5 has a probability of 2 out of 6 of occurring. Plus, you get nothing for 4 out of 6 things that could come up. So our expected outcome is 5/6. Nope, sorry, 5/3. So it's 10/6, which is 1.67. I'm going to do 1.667 because remember, you're not really supposed to be rounding this. I'm going to do 1.667. All right, so now if you play this game many times, your the amount you would win on average is 1.667 per game. How have you been doing the 10 times you have played the game compared to the expected payoff? Well, that's where what we just did on the last one is. So they have $4 8 out of 10 times, and they won $0 2 out of 10 times for an average of 4, right? So they have an average of 4, and the overall average should be 1.6667. So how have they been doing? Better than average, right? They've been doing much better than average. I could say more than twice as well as they should have, more than double the average. You can come up with ways to say that. So it's been doing super, super well. All right, so the reason this is a really good one for this next question is because sometimes they do like to give you graphs, and you have to be able to interpret your graph. Okay, so I'm going to give you a minute. I want you to calculate these probabilities. And you really need to look at the graph because the graph is trying to get across the idea of a discrete random variable. Instead of having the value on a line, the value is a block. So like, you need to think about this as this being, this is really 1, this is 2, this is 3, this is 4, and this is 5. If you think about that. And 0's over here. 0's at 0. Okay, then go back to the way you like it. If it makes sense to you the way you're thinking about it, you think about it differently than me, it's fine. Oh, I'm sorry. This is continuous. My bad. Duh. This is continuous. You're good. Think about it the way you were. I was turning it into discrete. Okay, so from 0 to 2 is all of this. Did you decide what that would be worth? 6 what?
60%.
60% or 6/10? How am I getting a tenth out of this?
Because if it's out of 1, then you could just split it up into 10.
Okay, so if you look at the blocks, you could split the blocks up and go, okay, well there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks. Do you see that they're tenths? You can also look at the scale on the side, and the scale on the side says this is 1/10, this is another tenth, this is another tenth. I wrote a 7. You get what I'm saying? So you could look at it either way, but the idea is that all of this has to add up to 1, so each of these must be a tenth. So this first question is 6/10. Now, this is the best visual for what is exactly 3. Does the value exactly 3 have any value at all? No, it is the line between 2 and 4, right? Less than 3 and greater than 3. The probability of being 3 is 0. Now, what is the probability of greater than 3? Is 1. That's this over here. So it's 1/10. You cannot have exactly 3, because 3 is exactly the line separating. Now, you can have less than 3, you can have greater than 3, but 3 itself is a line that separates the left from the right at the boundary line 3, and it has no mathematical value because it's a line. Because greater than 3 is all of this, and there is value over there. It's this. Yes. 3 is the split. Yes.
If it was discrete, could you have exactly 3?
Absolutely, and that's what I was trying to do at the beginning, is I thought this was discrete, and then when you guys looked at me and I read it, I was like, no, never mind, it's continuous. Yes. Okay. Move on, number 11. Let me check my answers. Yes, my answers are good. Move on. Bye, hon. What is the probability of very cold day? 0.15? 0.05? 0.15 is what I have. Okay, so look, hold on. If you turn this into a model, $20,000 is for a warm day, right? And you expect to have a cool day is $5,000, and the probability of a cool day is 0.25. You're going to have a loss of negative $12,000 if it is the remaining amount, which is a very cold day. A very cold day you had to figure out on your own to be 0.15. They gave you enough, but they didn't give you that one value. So your expected profit should be 20,000 times 0.60 plus 5,000 times 0.25 minus 12,000 times 0.15. So, and next you're going to have to put it in your calculator to calculate the standard deviation and the variance, unless you just like to do that by hand. So, I'm going to do 20,000 and 5,000 and negative 12,000 as my list 1. Then my list 2, I'm going to do 0.60, 0.25, and 0.15. Then I'm going to go stat, calculate, 1 var stat. List 1 is my list 2 is my frequency. See, Hannah? So my expected is $11,450. Did you guys get that? And you have to show this work, or at least some of this work. Then you must show work for the standard deviation, but you do not have to show a lot. So standard deviation is equal to 20,000 minus the mean squared times the probability plus ... and my answer is 11,693.91. So we did have a standard deviation larger than the mean. We said that that doesn't happen a lot, but we did. Yes?
So if you do the standard deviation in your calculator, you have to write the commands and stuff that you use, right?
No, you have to actually show me a piece of the formula.
Okay.
Yeah. It has to be a piece of the formula for full credit. Express the producer's expected profit and variance in terms of Mexican pesos. A US dollar is worth approximately, oh, I forgot to give you variance. Variance is 11,693.91 squared. So the variance is 13,6747531.1. This would be the variance. Because the variance is just standard deviation squared. Yes.
How do you have some class figure it out on the graphing calculator? Like, I know the list, but then when you do standard deviations.
You go to stat, calc, 1 var stat. Stat, calc, 1 var stat. And you should have list 1 is L1 and your frequency should say list 2. Okay? So if we have to express his profit and variance in terms of Mexican pesos, the mean is 11,450 times 11 pesos. And that ends up being 125,950 pesos. And then for standard deviation, it would be 11,693.91 times 11. 11,693.91 times 11. That's my standard deviation, 12,863.01. My variance is that squared, which is a large number. It's 1.6546 times 10 to the 10th power. Yes. Yeah, standard deviation has units, but variance does not, because it would not make sense if I said squared pesos. Like there's no such thing as a squared peso. So, all right, you ready for me to go on? No? Okay, I'm waiting. You can go on without me. You're so lucky there's still like a pages left. We get to do more and more and more. There's 3 pages of fun left. And if you get to where you have to leave, I understand you have to leave. I get it. But we're going to keep on working. All right, so here's your next one, and this is great. This is an old free response question. Okay, so Hanover High School has the best women's swim team in the region. The 400-meter freestyle relay team is undefeated. In the 400-meter relay, each swimmer swims 100 meters. The time in seconds for the 4 swimmers, it tells you, is normally distributed. So now you've been told you're allowed to use a normal curve. Find the mean and the standard deviation for the total team. So more variables means more variability. Things should be growing here. So I'm going to say that the mean is equal to Wendy plus Jill plus Carmen plus Latrice. And that will be my mean, so I'm adding those up. And I have that my new mean is 224.2 seconds, right? Now, standard deviation would be the square root of each person's standard deviation squared, which is their variance. So 2.8 squared plus 3.0 squared plus 2.6 squared plus 2.7 squared. And I have that the standard deviation is 5.558. Why is it higher than each individual person? Because it's combined. And when you combine more variables, you're going to expect more variability. So we expect it to go up. Yes?
So when do we do the same deviation, like that exact thing, but with minus the mean? Like it's like minus mean, or mean minus x squared plus mean minus.
That's if I'm calculating, okay, that is if I have a probability distribution and I want the standard deviation of the probability distribution. So you're asking me this formula right here. The value minus the mean squared times the probability. So this is a probability distribution. And this is how we calculate standard deviation. Okay, that's probability distribution. There are probabilities involved. If you look at this, there are no probabilities involved. I'm combining variables. So I'm combining Wendy, Jill, Carmen, and Latrice, and I take each person's variance, which is standard deviation squared. I add it up, and I square root it. That's a good question, because I think people just said, oh. Okay, suppose the mean height of a policeman is 70 inches and the standard deviation is 3. And suppose the mean height for a police woman is 65 inches with a standard deviation of 2.5. If the heights of the policemen and policewomen are normally distributed, find the probability that a randomly selected policewoman is taller than a randomly selected policeman. Now, I want to tell you that if A is normally distributed and B is normally distributed, then if you add or subtract, guess what? It's normally distributed. So you could have a question that says if you add 2 normally distributed variables, what is their, what shape is the outcome going to have? You're going to say, well, it's normally distributed. Okay, it keeps that same shape. So here you go, number 13. This is a great question. Draw yourself a little curve. I'm going to hit pause because this is getting really... All right, so if you have a, if you are subtracting and you want the police man minus police woman. So the mean of man minus woman, then we would have 70 minus 65, which is 5. The standard deviation of man minus woman is the square root of the man squared plus the woman. You never subtract. More variables is more variability. So 9 plus 2.5 squared, and I'm going to square root it. So I got 3.905, yes? Now, I'm going to draw this curve. 5 is what I expect. If the woman is taller than the man, what type of answer would their subtraction be? Negative. It's going to be at 0 or less. If the man is taller than the woman, so if Penton is 5'5" and I'm 5'3", and we subtract, it's going to be 2, right? But if Penton is 5'5" and Maddie is 5'8", because she's taller and you subtract, you're going to get -3. So that means she is taller than him. Okay, so this is the idea that the man minus the woman is 5. But if you come over here and the man minus the woman is a negative number, that's because the woman was taller. So we are going to norm CDF. My lower is -10,000. My upper is 0. My mu is 5. And my sigma is 3.905. Second vars, norm CDF, -10,000, 0, 5, 3.905. And it's 0.1002. Well, remember. Okay, so hold on. What is your question?
So how come, like on the graph, it's behind 0?
Because if it's here like 4, the man is taller than the woman by 4. If it's 3, the man is taller than the woman by 3. If it's 2, the man is taller by 2. 1, 0, they're the same. But remember, 0, the line, has no value in a continuous normal distribution. So everything on this side has value. These are the negative numbers where the man is shorter than the woman. So when we subtract, we get a negative. All right, suppose you roll a pair of dice 100 times. Let x be the number of times you roll doubles. Does x follow a binomial or geometric distribution? Explain. That is bins. What are the 2 outcomes? Yep, doubles or not. Independent. When you're rolling dice, does rolling a 6 mean you won't get a 6 again? Nope, each is independent. Is our number of trials set? Yes. How many do we have? 100. And the probability of success, you might not remember this, is 6 out of 36 or 1/6. Because that'd be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, or 6, 6. So there's a total of 36 outcomes, and that is 6 out of 36. So that is why it's binomial. Next, what are your mean and standard deviation? That is on your formula sheet. So your mean on your formula sheet is NP. Your standard deviation is the square root of N times P times 1 minus P. So your mean is 100 times 1/6, which is 16.667. And my standard deviation is the square root of 100 times 1/6 times 5/6, because that's success times failure. I get 3.727. Yes, we're good on using that. Good. It's on our reference sheet. Now, we're going to need that, I think. Find the probability that you roll doubles exactly 17 times. So my probability of doubles is 1/6. So how is our number of trials set? How many are there? 100. Is this a binomial PDF or binomial CDF? PDF, because it's exactly 17. So this is binom PDF x equals 17. To get credit on this question, you must show me more than calculator speak. Trials is 100. Probability of success is 1/6. Number of successes is 17. You've got to show me that to get credit. So 100, 1/6, 17, and you should get 0.1052. All right, D, find the probability that you roll doubles 8 or fewer times. So is that, it's still binomial because we have 100 trials. Is that CDF or PDF? CDF, because it's 8 or fewer. So we want the probability that x is less than or equal to 8. Do I need to subtract from 1? No, this is the direction that the calculator works. Your calculator understands 8 or fewer as being less than or equal to 8. It always works on the left side, the less than, never the greater, unless it does a tail. So this is a binom CDF. My trials is 100. My prob of success is 1/6. My number of successes is 8, or fewer, of course. So binom CDF, 100 trials, 1/6, and 8. And I get 0.0095. Next, it says find the probability that you roll doubles 20 or more times. So your probability of x is greater than or equal to 20. Can you do greater than or equal to 20? What do you have to subtract out? So it's 1 minus the probability that x is less than or equal to? Yeah, you're thinking about wrong. It has to do with this. If you win at 20, 21, 22, 23, I want to subtract out the flip side because I'm doing the complement. 19. So it's less than or equal to 19 is what you're subtracting out. So it is 1 minus, is it PDF or CDF? Yep, binom CDF, x is less than or equal to 19. 0.2197. Is it safe to assume that it's approximately normal? We had that today on your quiz. We talked about it. It's what I taught in the end of chapter 6. I had taught it in the video, and it is called large counts. To satisfy large counts, n times p has to be greater than or equal to 10. N times 1 minus p is greater than or equal to 10. So 100 times 1/6 is 16.67, which is greater than or equal to 10. Check. 100 times 5/6 is 500 divided by 6 is 83.3, which is greater than or equal to 10. Check. Yes, it is safe to assume approximately normal. If you can satisfy large counts, you can assume it is approximately normal. Now you're going to use the normal approximation to find this, 15 to 20. Oops, I'm doing that wrong. Okay, it doesn't matter where you mark, 15 to 20. What is our mean? You should have, didn't we calculate the mean on the front page? We said our mean is 16.667 and our standard deviation is 3.727. So this is 16.667 and my mean is 16.667 and my standard deviation is, I have it on, what did we say? 3.727. So I'm going to norm CDF. My lower is 15, my upper is 20, my mean is 16.667, and my standard deviation is 3.727. And the answer is 0.4871. Make sense? Okay, on the next one, a family wants to have a girl. What's the probability that they don't get a girl until their 4th child? What is that? Okay, and they're saying it's kind of like they get it on their 4th child. So it is exactly 4. But what type of distribution is this? Geometric, because they're going to try until success. So they're going to try until 4. So this is a PDF. So this is a geomet PDF of x is equal to 4. Now, you can also think about this, which is my way of thinking about it, is failure, 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 success. It's weird because it's 0.5, so the success and failure has the same probability, but what I'm doing is failure, 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 success. So it's actually 0.5 to the 4th power, which is 0.0625 is a probability that they do not get a girl until their 4th try. And if you did second VARS and you did geometric PDF, so PDF, our probability of success is 0.5, and on the fourth trial, you will get the exact same answer we just got. So you could do it by thinking, like listing it out, or you can do it by plugging it in. Okay, last little bit and we're done. This is our last question, right? No?
Yes.
Yes, I was going to say this is epic. All right, we can do it. This is geometric. So does it follow a binomial or geometric distribution? Approximately 20% of the students in the College of Science and Engineering at the U of M are female. Let X be the number of people you encounter at the College of Science and Engineering before you meet a female who is in the College of Science and Engineering. So this is the number of people until success. This is geometric. So you have to show me that it's geometric, and if you'll remember, it is bits, B-I-T-S. So it's binary because it's either a male or female. So male or female. I, each person is independent. T, you're going to try until success. And success is 0.20 of getting a female, and it is fixed. Now, this is really great because we haven't practiced this in a little bit. On your reference sheet, you have the formula for geometric. You have the standard deviation, and you have the mean and the standard deviation. So find the mean of X. You got your little reference sheet. Your little reference sheet says the mu of Y is 1 over P. So 1 divided by 0.20 tells you that the mean is 5, right? What's the probability that the first female you meet is the 7th person you encounter? Is that, we already know it's geometric. Is that PDF or CDF? PDF. So this is geomet, PDF of X is equal to 7. So my probability is 0.20. My number is 7. So I'm going to second VARS. I have 0.0524. Now, I want to show you that this is the same thing as saying, okay, I've got 4, 5, 6, 7. I have male, 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 and then female. If you did this math, 0.8 to the 6th power times 0.2, you'll get the same answer. And you might see like a multiple choice that has it written out like that, where you got to look at it and go, okay, yeah, that's 7 trials, this is 6 failures and 1 success. All right, find the probability that the first female you meet is after meeting 9 males. So, does it mean it's absolutely on the 10th? Yeah, okay, so we can do binom PDF, X equals 10. But what if you got him on your 11th? Would that mean it's after 10? What if you met a female on your 15th? Is that after 9? What do you think? Okay, and I agree with you, but I think you have to read into it a little bit. It doesn't, if it wanted to say, it would say, what is the probability you have to meet exactly 9 men before you meet a female? That's what it would say. So this is actually a CDF. X is greater than or equal to 10. It's geometric. Sorry. My bad. Good job. Nice save. It's geometric CDF. X is greater than or equal to 10. So your 10th is a female, or your 11th is a female, or your 12th is a female, or your 13th is a female, but all of these people are males, and you have at least 9 of them. So how would you do greater than or equal to 10? 1 minus geomet CDF of X is less than or equal to 9. So I'm going to do 1 minus so my probability of meeting a female is 0.2, and my X value is 9.1342, which means it's pretty likely it's going to take a lot of meeting a lot of men before you meet a woman, which makes sense because that's the probability of that's the makeup.
What if you walk into a whole room
Full of women?
I mean, like just mix with 9 people, and then you just should be women there, so.
You would think on average. Yeah. Okay, find the probability that the first female you meet is on or before the 5th person you meet. So that's binom. Sorry, it's geomet. What? CDF. X is less than or equal to 5 because it's on or before the 5th. So it's saying add up the 5th and everyone before the 5th. Do you have to subtract from 1? No. So second vars, geomet, CDF. My probability is 0.2 and my success is 5. So it's 0.67232. And last, how many males would you expect to meet before finding the first female? That was pretty quick. Okay. No, but I like that you said that. Your thinking is 8 out of 10, right?
Yeah.
So the answer is 4. So let's talk about why. Okay. So your probability of meeting a male, the probability that it's a male is 0.8. Right? Ooh, I don't even like this. And your probability of a female is 0.2. So if you do 1 divided by 0.2, you get 5. So it should take 5 people to get a female. That's the expected number of trials it's going to take to get a female. So how many trials would you expect to take? How many trials would you expect to see a male before you finally see a female? 4. Because if it takes 5 trials and you see a female on the 5th trial, then what are you seeing on all these trials before you see a female? You're seeing males. I was thinking of this 0.8 times 10 is 4, but I can't figure out why I'm thinking that. but it doesn't matter. I wouldn't even go with that as mattering. This is what matters. If you're expecting to have 5 trials before you hit a female, then your first 4 must be males.
Like 28 times 5. 28 times 3.
Oh yeah, 0.8 times 5, I'm just thinking what I'm doing. 80% of what you see in the 5 people would be males. That's where the 4 comes in. But this makes sense to me. If the 5th trial is a female, then the first 4 must have been males. That's the only other option. All right, so we are